I'm Davide Ferrari, General Director of Sagea Group. Sagea is a leading European private and independent company working in different areas for registration of agrochemical, plant protection products and biostimulants. We started the company in 1997 in Italy. And then we spread organically in different regions, particularly in south and the southeastern part of Europe. In the rest part of Europe, we are present with partnership. So this means that we offer a service to project management to our client to manage a full project in all the different countries in Europe. This means that we can offer a wide range of services from efficacy and selectivity trials to residue and ecotox studies to processing studies that more and more are requested to fulfill the dossier for the registration of a plant protection product. And the areas that are not directly covered, like toxicology or E-Fate, are managed in partnership with external partners. We are more than 100 experts working in different countries and in different areas, and this means that we can really offer service in partnership with our client, that is mainly the agrochemical and the biostimulant company, to provide and to present to the authority the full dossier coming from the data that we got from the field and laboratory phases. So today we are happy to show you what we can offer from the field to the laboratory to the analysis of data until the end of the dossier preparation and the archiving of all our experimental activity to provide to our client that then will use to register a new product for the use in agriculture, both as a plant protection product or biostimulant, depending to the purpose. Thank you.
My name is Ivo Rovetto and I am a project manager and study director for GEP and GLP studies in Sagea Group. And I would like to discuss briefly about the issue of how to deal with the calculation of the dose rate for the application of plant protection products. Mainly because since 2016 there is a big discussion, mainly at Central European level, about the type of calculation for vertical crops. Vertical crops means grapevine, fruit orchards and high growing vegetable crop. In this case, after the workshop held in Vienna in 2016 about the necessity of harmonization of the calculation of rate to be applied to the vertical crops, it has been defined the definition of leaf wall area. Leaf wall area has a specific formula to be calculated, and it is a way to express the actual surface of vertical crops to be applied. This means that in the past, the calculation of plant protection product rates was based on the ground area. Normally we calculate the amount as milliliter or grams for hectare. In this case, we have to switch to another way to calculate the rate, which is square meter of leaf wall area. This is due to the necessity, according to the Central European Registration Zone, to calculate in a uniform way the amount applied to the vertical crops, and also the main aim of this new type of calculation is to reduce the unnecessary emission of plant protection products to the environment, and consequently the residues in food and feed. And so it is now some years that we receive from our client the request to calculate the rate of the plant protection products to be applied in our trials using this new unit of rate calculation. At European level, it is fixed from the regulator authorities a number of efficacy trials necessary for the registration of the plant protection products. This is mainly indicated in the EPPO guideline number 226, where this minimum or indicative number of trials is reported. And how the number of necessary trial is calculated depends on the type of crop and type of pest. Normally we speak about major crops and major pests. Major crops is represented by all the more present and developed crops across Europe, and the major pests are the pests that are normally present and able to cause strong damages and economical losses to the crops. In this case, speaking about major crops and major pests, the number of requested trials is 10, split in 2 years. This is necessary to cover as much as possible geographical areas and also differences in weather conditions. If we consider the crops in protected conditions, and so in greenhouses, the number of efficacy trials could be reduced to 6. And these trials can be done only in 1 year. This is quite clear because the conditions in the greenhouses and in the protected conditions are more similar, even if we are placing these crops in different areas across Europe. But the greenhouse allow to reduce the variability of weather, mainly of weather conditions. If we have minor crops or minor pests, the number of trials can be reduced to 3 or 4. In general, these numbers are only an indication, because it is finally the role of the regulatory authorities to decide if all the trials presented into the registration dossier are good and valid, or if additional data and so additional trials must be presented. And so in this case the client is requested by the regulatory authority to offer to present other trials to complete the dossier. there is anyway the possibility to not only to increase the number of trials but also to reduce the number of trials to be presented in some particular cases. We have already mentioned about the greenhouse and the protected conditions that allow to reduce the number of necessary efficacy trials, but we also can consider the case of the data extrapolation. This means that if we have a lot of consistent data from major crops, we can use this data to extend the registration to minor uses or minor crops, using mostly the data already available on the major crops and major pests, and so the number of necessary trials in this case can be reduced. What it is important is that there are specific rules for the extrapolation. One of them is that we can use, we can say, challenging trials. This means trials made in very important crops with very important and consistent results to adapt this data for the extrapolation to minor crops or minor uses, not the contrary, we can say. In the EPPO guideline 2226 is specified that, for example, we can use for the application of dense crops with dense foliage, we can use this information for crops that have a less dense foliage. In this case, the foliage less dense allow the application to reach better the crop canopy. Other cases for the reduction of the number of necessary trials can be some exceptional circumstances. For example, if we consider very special pests, for example quarantine pests, or the registration of pheromones. If we have to register pheromones, we need to perform trials in very big surfaces, and this can be a reason to reduce the number of necessary trials. But also, for example, if we have to register products for the fumigation of warehouses or structures, and so in these cases we have to spray, to apply the product in very big surfaces, and again this can be a reason to reduce the number of trials to be presented. Anyway, what it is very important is that this point have to be clearly discussed with the authorities, because they can evaluate all the available data and they can decide if they are enough or if more data have to be created and presented.
We are in the field experimental station, and today we are setting up and sowing insecticide trial for registration. When you register insecticide by soil application, like in this case, you can do by application in furrow or by seed treatment. In this case, we are testing a seed treatment product. So our colleagues on the experimental sowing machine are setting up this trial. So this means that the layout was organized in the office, because the machine is connected to the GPS and is self-driven. So this means that all the plots, according to the EPPO guidelines, are already planned by the machine. So now every single plot is sown using replication with different dosage rate of the seed treatment. And when the corn will germinate, we will define the exact plot size, and subsequently we will assess the pest. In this case, it could be wireworms or Diabrotica virgifera, that are the two main pests for corn. And the assessment will be when the corn will be at the BBCH 14, 16, depending to the pest, and we'll be checking the roots. So means we will dig off some plants, we will assess the larvae on the roots, and using a scale that, talking about Diabrotica virgifera, is Iowa scale 0-3, we will provide some number that we will subsequently elaborate using a special informatic program to do the statistic analysis, to write the final report, and then to have a report to use for the dossier for the registration of a new insecticide for this crop.
Good morning, I'm Paolo Viglione, Technical Director of Sagea Group. Here we are in the wine cellar where we perform microvinification test. Microvinification test started in the field. Field phase is a bit different than standard efficacy trial because, first of all, we didn't have the untreated control. We just need a treated control with a standard product, well-known standard product, that we already know that it hasn't any negative side effect on the vinification phase. And for sure, our test product sprayed in a we can say in a worst case situation. It means that we have to spray following the gap, but arriving just right to the pHI and using the lower spray interval and the higher dose rate indicated in the label. When the bunches arrive here, we have to monitoring the main qualitative parameter. After the evaluation of the qualitative parameter, we can proceed with, first of all, with the crushing for red varieties or with the pressing for white varieties. And after we put the mousse in the tank. And now started the most important phase for the microvinification, the alcoholic fermentation. Every day we monitor the temperature and the sugar level. It's very important that the alcoholic fermentation proceed at the same level for both the treated plots, because most of the side effects that we can see on the microvinification are related to the alcoholic fermentation, and particularly on the yeast. Some products, partially I can say in the past, can cause some issue to the yeast. After the alcoholic fermentation, we go ahead with the other phase in order to arrive to produce a bottle of wine. In this wine cellar, we have to simulate in a small scale what happened in a real wine cellar, in a big winery. After the bottling, 1 month after the bottling and 1 year after the bottling, we have to evaluate also any possible side effect on the organoleptic parameters. And particularly we have to make a TAIN test, a triangle test, where we perform a sensory analysis to evaluate if there is any possible difference between the two treated plots. Fill phase, processing phase and sensory analysis are performed following specific EPO guidelines.
We are in a Sagea experimental apple orchard, and this trial is a trial against aphids on apple, where we go to test the efficacy of different products. In particular, in this trial we have 4 theses, where we go to test 2 different dosage rates of the test item in comparison to the untreated check and to an untreated control. Each thesis is replicated 4 times, and each replication is composed by 5 trees. Now, we are marking some shoots where we go to check the level of the infestation of our population. Then we perform assessment before the first application in order to check the level, and then at precise timing, in particular 3 days after the first application, 7, 14 and 21. We perform assessment on the marked shoots previously selected, counting the number of aphids and inserting the data on the tablet.
Good morning, I'm Marco Moizio and I'm team leader in Sagea Group for fruit trial in all South Europe. Today I will try to explain you what happened about the data when we collect them in the field and how we manage them for analyze the data in terms of statistical and efficacy results. Here you will see that when technicians come back from the field with the data collected in a digital way, so Excel sheets for example, we will use it to introduce in the ARM file is software, statistical software that we used to analyze the data. But before to use this software, we have to prepare the raw data arrived from the field before to make this type of procedure. This is the table concerning the raw data arrived from the field. You see that here you have the number of treatments from 1 till 7, and here in the first column you have the replication. First, second, third and fourth replication in this case of this type of trials. Then we have to manage this raw data before we to insert in the RM file, because we have to order the data according to the treatments. Thus we create the new table here with treatments, number 1 replication 1, number 1 replication 2, etc. until the end with treatment number 7 for replications. Then we insert the same data collected in the field, and at the end we had 25 shoots observed per plot, so 1 number of aphids per marked shoots. And here, using Excel, we can obtain the total number of aphids, the average number of aphids, and the relative incidence calculated on these 25 shoots observed. After this, these 3 columns are ready for copy and paste in this way in the software ARM statistical analysis. You copy and paste, all columns that you need. When we arrive at this point, we moved in RM file, that this is the graphic, and you see how the columns are similar to an Excel sheets, and here we had to just copy and paste the same value that we obtained in the previously Excel. 2 and 3. Of course, you have more columns according to the number of assessment performed, according to different type of target that we are going to evaluate, or different columns in terms of statistical analysis that we are going to perform. This because the raw data, when we insert in the RM, he have to manage in the particular way according to our needs. For example, here we have the raw data according to the number of insect on 50 shoots observed, for example, because this trial wanted 50 shoots per each plot. Then we have, like before, the same basic number counted on 50 shoots, and this is the relative percentage of incidence on the number of the shoots controlled. After that, this is the raw data. These are the efficacy calculation arriving from these columns, because number 1, second replication, third replication, fourth replications is 0, because we exclude untreated check from the efficacy calculation in this way. So RM put for us value as 0, and all the rest is the relative efficacy in percentage per each treatment, group of treatments, according to the untreated check results. We did and we do the same for all columns and for assessments that we perform during the trial period, and we usually use in GLP trials two different type of calculation for the efficacy, thus to give the real value, the right value about the efficacy. That is Abbott test and Anderson-Tilton test. That Abbott test when you don't have infestation or infection at the beginning of the trials, or using Anderson-Tilton transformation when at the beginning of the trial the data are not homogeneous, or anyway if you have preliminary data before the first application that we had to perform. When we obtain this type of columns, the ARM file is considered complete, and after a check with the sponsor, because we had to know if we have our focus on the same aims and on the same particular things that sponsor wanted to receive, we are ready to perform the final reports that we will use to send to the sponsor as final documents. For that, we have to print this type of tables, plus other information, general information, we call like that, present in each ARM file, and then we create our format report. Format report is this one. For example, that this is the results about statistical analysis arriving by RM software. You will see that per each columns we have statistical analysis and the relative average per each treatment. Okay? Then per each incidence columns we calculate the relative efficacy, in this case with Abbott test, excluding control of column number 21st, that is this one. And this is the relative efficacy with the specific statistical letter per each treatment that we did, that we evaluated. After, we create graphs in order to give a fast landscape, a fast peek about the results obtained from the trial. And after graphs, we start the discussion regarding the results about the trial. So at the beginning, a little description for the trial site, then the description about the treatment list, after 2 words regarding the application timing and the relative BBCH. After that, discussion about the data collected throughout the trial period, some sentence about phytotoxicity. In this case it's very short because no symptoms was observed, but if we checked phytotoxicity, we have to describe in similar way to the efficacy results also the phytotoxicity performance. At the end, we have a conclusion part where we try to give a general indication about the infection level and how the infection was present in terms of incidence and severity on the untreated control. So if a medium infestation, a remarkable infestation, high infestation, and more, then we describe any difference between untreated check and treatments, and if we obtain something good, we can also describe the difference observed among treatments, and then a little sentence about phytotoxicity during the trial period. After, we have a trial map, like a randomization according to the EPO guidelines for the trial, weather data, because it's important to understand the temperatures, rainfalls, and other environment parameters that can be helpful for understand the disease behavior. And here we put the raw data that are the same data that we inserted in the ARM, because you see that you have 4 numbers, 1 per each replication, per each treatment. And then our GCP certification.